Okay, hey guys, so we're still in simplifying square roots. I'm going to give you an alternate method to simplifying a square root, and instead of breaking it down into its prime parts, we're going to use the greatest perfect square that is a factor of what we are trying to square root. So let me show you what that looks like. Okay, so alternative method. Finding the greatest perfect square factor. Okay, here we go. So we need that list of perfect squares that we jotted down in the beginning of our notes. Let's just write it again for the sake of practice and repetition. So perfect squares. Oh, I did not mean to select that. Can I undo it? Okay. So your perfect squares are 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, again, I did that last time too, 64, 9 times 9, 10 times 10, 11, and 12. Again, this list could keep going if you wanted to, but this is enough for our purpose. So if I had, let's say, the square root of 72. I would want to divide 72 by each one of these perfect squares until I can't divide anymore to see which one of the perfect squares divides into 72. So let's try it. So in your calculator, we are going to divide divide 72 by each perfect square. Until we find one that divides into our factor. So I'm going to take 72. I won't divide it by 1 because 72 will be divisible by 1, so we're going to kind of ignore that. I'm going to start with 4. 72 divided by 4 is 18, so that's a possibility. So I'm just going to write that down and record that as a possibility. Oh, 74 divided by 4. Nope. 72 divided by 4. That's what it says in my calculator. Sorry. But I'm just going to keep trying because 4 might be the biggest perfect square factor that lives in 72, but it might not be. So I'm just going to keep checking until we reach 64. Obviously, we won't be able to divide 81 into 72 because 81 is bigger than 72. So I'm going to keep going. I'm going to do 72 divided by 9. That's 8. So again, that worked because it's not giving me a decimal in my calculator, and I'll show you what you do with the information after this. 72 divided by 16. doesn't work because it says 4.5. 72 divided by 25 doesn't work. It says 2.88. 72 divided by 36 is 2. Okay. 72 divided by 49 is 1.46. Nope. 72 divided by 64 is 1.125. So I'm not going to use any numbers bigger than 72 because then I can't multiply 81 by another whole number to get a 72. It would have to be some fraction of a number. So what I have here is I have 3 options. 4 worked, 9 worked, and 36 worked, but I want the greatest. I want the greatest perfect square. Great, oh, I can't spell greatest. So I'm going to use the fact that 36 times 2 is 72. So what we're doing is kind of the same idea as your prime factorization, but it's just going to kind of streamline things for us. So I know that 72 is 2 times 36. 2 is prime, but 36 is 6 times 6. And right here, this is my pair of numbers. And anytime we see a pair, 1 comes out. So the answer here is going to be 6, and square root 2 will stay in. Oh. Away. Okay, so here's your answer, 6 square root 2. So let's do that one more time, and then I'll let you try a couple. All right, let's do square root of 48. So I'm going through the list. I'm going to divide by 4 first. And it gives 12. So that's an option. 48 divided by, again, I'm getting this list of numbers. So the next one I'm going to divide by is 9. 48 divided by 9 is 5.3. So that tells me 9 is not a factor of 48. So I'll do 48 divided by 16 is 3. So I like that one. I'll keep going until I get to 36, just to make sure I get the greatest one. 48 divided by 25 is 1.92. That one doesn't work. 48 divided by 36 is 1.33. I'm not going to divide 48 by anything larger than itself. So here is my greatest. Again, I can't spell greatest. I don't know what's going on here. So I'm going to use 16 and 3 to break 48. So I've got 3 is prime. That's good. And 16 is a perfect square. It's 4 times 4. I would not want to break this into 2 times 8. That's not what we're looking for. We're trying to use the fact that this is a perfect square. It has a pair in it, because that's what we're trying to simplify. So I have this pair here. 1 comes out, only one of them. So 4, because there's a pair, 4 can come out. And this leftover 3 stays in. So that would be your final answer. Okay, so I'd like you to try a couple, and then we'll come back together and see how that is going. So again, this is your opportunity to put these concepts to the test. Did you understand what the lesson was showing you? If you don't like this method and you want extra practice with the prime factorization method, you can totally do that here. It's just 2 different routes to the same destination. So practice either way. Okay, please write these in your notebook, hit pause, and check back in just a minute to check your work. Okay, how did you do? I got 2 root 6 for number 1. So in this method, you know that the greatest perfect square, the greatest number that has a pair, is here. So you don't have to break 6 into 2 and 3 because there is not another perfect square or another pair that lives in 6. So I don't have to break that down because I can't square root it. Here, the 10, again, I don't have to break that down. I only have to break down the 9 because it has a pair in it. 10 is 2 times 5, so it doesn't have a pair. That's just a nuance to this method instead of the prime factorization method. So this was 3 root 10. And then our last one, 75, 3 is prime. So I knew that wasn't going to go any further. So this is kind of like prime factorization in a way. We had a pair of 5, so 1, 5 comes out, and the 3 stays in. So hopefully this is helpful if you are having a little bit of trouble with the other way of doing it. If not, please let Coach Stanley or myself know, and we will help you out. Thanks, guys.